will join us shortly. Good afternoon, everyone, and welcome to Understanding Your Soil Test. This is a training designed for folks who are interested in understanding, what's involved in sampling soil and analyzing in the analysis of the soil. We're here today at the Clemson University Ag Services Lab, where if you're using Clemson for your soil testing, this is the location where your samples are sent and analyzed. We are going to, I'll introduce myself. I'm Kelly Flynn. I'm the coordinator of the Emerging Crops program here at Clemson University. And I am also the upstate coordinator of the South Carolina New and Beginning Farmer program. So essentially, we've organized this training with the new and beginning farmers in mind. However, we do have some people who are not involved in the program joining us today as well. So thank you for joining us. It's nice to have you all here. Today we're going to be hearing from Shannon Alford, who is the director here at the Ag Services Lab, and Kerrie Roach. She's one of our local extension agents here for Clemson University. And they're both going to be talking about different aspects of soil testing and interpreting the results. So just to give you a quick overview, we're going to start out with a tour of the actual lab here. I'm going to sort of disappear for a second and meet Shannon in the back of the lab, and she's going to take over and kind of show you around the different parts of the laboratory here. And then she's going to do a presentation on some soil chemistry and talk about taking soil samples. And then Kerrie's going to pick up after Shannon and talk to us about interpreting the results on your soil test and applying them to your individual operations. So there's going to be a couple of little breaks here. Right now, I'm going to disappear for a second while I make my way to the back of the building. And so if you all could just hold tight for just a minute here, we're going to regroup and get started with the tour. All righty. Well, I'm turning this over to Shannon Alford, the director here at the Ag Services Lab, and she's going to take us through a tour here at the lab.
All right. Hello, everyone. Welcome to the Clemson University Agricultural Service Laboratory. If you can't hear me, please let Kerrie know, and we'll get that information. But I'm Dr. Alford. I'm the director here. I've been in this position for about 5 years. And I also have here with me one of our chemists, Amy, and then one of our research associates, Michael. And they are both also going to help with the lab tour today. In fact, we are currently in the sample receiving and soil prep area of the laboratory, and Michael is going to share with you what we do with soil samples when we receive them here in the lab. So he's going to just tell you about how we process things.
So my name's Michael. I've been here at Clemson 23 years, and we have a loading dock. We receive most of our samples through UPS. During the pandemic, also, we started receiving almost all of our samples through the regular mail, so the post office. And we still have a lot of clients and customers using that. So UPS and mail drops once a day. We'll have a cart with big boxes full of soil, and inside those boxes are bags of soil. And you can see, or maybe there's an address and your county and what you're growing, but there's also information. That information is recorded here on our sheets. There's also an information sheet that will allow you to put in crop codes, soil types, all kind of information about how we can contact you, because we email our results. So that's very important. There's a fill line right here. So if you guys are ever taking soil samples, there's instructions on the back of the bag. But you guys are farmers, I understand, so you'll hear all about how to do that. So one of the most important things back here in our sample receiving area is this number. This is a set number. 21 is the year, 08 is August, and then these are the lab numbers, 0001. So we're just now starting August. We have already finished all of our soil that came in during July. That is almost done. It'll be done in an hour or so. So if you had stuff sent here in July, it's finished. And so we're really good on our turnaround time. Usually 3 days during 2 to 3 days during the summer. And during the busy season, we were staying down to 3, 4, less than a week turnaround, which we were very proud of. And part of that is because of people like Amy, the chemist, and a few of the other chemists we have who are very diligent and work very hard at getting these things turned around. And we have a lot of improvements also back here in this area. We have new soil grinders. They've been refurbished. We also have new drying ovens that are behind us. And yes, we can point out the drying oven. This is a big step up for us. I know it kind of looks like a big battleship, but before this was all plywood and it was not insulated. So you can actually see the soil in there drying. So there's heaters at the bottom, and then there's a fan that pushes air across. We usually like to let these, if we can, dry overnight. And then next morning we'll pull them out and start our grinding procedure. Over here are our 2 grinders. We don't have them named yet, but these are the grinders. There's a hopper here. There's an air filtration system that pulls out all the silica dust. And we wear hearing protection and goggles, and they're not that loud. So there's a shaker here that when the soil passes through, it gets ground. The roots and rocks and other things that aren't soil get chafed out and go down to the bottom. And that's actually the grinder mechanism. So we wanted that soil to be in a uniform consistency, so that when we go to, you'll see this in the other parts of the lab, when we go to scoop and take a soil sample, it's very uniform. So we're providing customers with, good results, accurate results. And we usually find that from one bag of soil, if it's ground and it's uniform, that we can achieve the same result for that entire bag. So there you might have 15 or 20 samples that you could pull from that one bag of soil, and they're all within a short range of, so we're very accurate. We also partake in proficiency programs. So those are like national programs where we send off results to see how we're doing against other labs and against a lot of known standards. And all of our mineral analysis and our pH analysis, all of those have known standards that are included with each soil set. We run 100 soil set soils at a time, and there's 2 to 3 checks, and sometimes even more in each set. So if the checks match up, then we know our instrumentation is working properly. This is a very busy area back here, especially in the winter when people are prepping for the spring planting. You'll see that our entire oven will be full. It can hold 1,400 samples, and we'll also have stuff on the countertops and stored in different places. So if we have time for any questions, but is there anything else?
Are we doing questions in between?
I think let's save questions towards the end.
All right. So after the soil, I'll step over here. After the soil is dried in the ovens that Michael showed you, and then in these 2 grinders, then we move the set, as he was referring to it, the 100 soil samples, into the laboratory section of the building. So this is really our kind of pre-prep area for our soil samples, and then we move on to where we start doing some chemistry with the samples. So we'll go ahead and walk that way. It's one of our other chemists here, Sam. And I'm gonna do this part. So in this particular room, which if Kelly were to pan out, maybe show you all around, there's a lot of soil samples in this room that we have already analyzed. So I think of this as our soil library. So if a customer wants us to recheck or decides they want another test, we keep soil samples around just to try to accommodate any extra requests. But the samples that we're currently working on are here on the lab benches. And so what we're going to tell you about is the 2-part standard soil test that we do for almost every sample that comes through the lab. And we analyze between 40 to 50,000 soil samples annually. So we have a lot of soil samples coming through these lab benches. But right now, Michael mentioned, July is a really quick turnaround time because it's summer. But once we get into fall planting and then getting fields ready for spring, that's when things really kick up around here. But what we do for our 2-part standard test, which I will talk more about later as well, we've got our 100 samples here. They've been dried and ground. And if you were to look, I don't know if the camera can look through. If you were to see some of these samples, they're really finely ground material. And we've got, yeah, maybe hold up the whole tray. So these have come out of the grinder, and we're going to actually scoop them for 2 separate tests that we do. So the first test is going to be our nutrient analysis. And for that, we're looking at the minerals that your soil contains. So that would tell you, potentially what fertilizer you might need to add depending on the nutrient content. Well, we use these scoops, which are actually standard volume scoops. These are issued from some of those proficiency programs. So every lab that does this kind of work uses these kinds of pieces of equipment. But we just scoop a sample, tap. This is a standardized procedure. Scrape so that we've got, it's kind of like sifting flour, right, for cooking a little bit. And we've got these cup systems for our extraction process. And so we're going to scoop every sample into a cup. And these are all numbered so that we know which sample goes in which cup so that we don't get anything out of order. So we know exactly which sample we're working with. So anyway, we're going to dispense that into a cup, and then I would move along for every single sample for the nutrient analysis, but I'm not going to do that right now. Yeah, you can see the numbers on the cup system. So once we've gotten these full of our soil samples, we're actually going to add extraction solution. So I'm going to walk over here and show you this setup. So we've got an automated dispenser for our extraction solution, which I'll tell you a little bit more about later. But anyway, if I had 100 samples, I would dispense liquid into each of these cups. And then we're going to shake this in our shaker system. So it's like an incubation process to pull out those nutrients from the solid into a liquid solution. So imagine these cups are full of a slurry of your soil and your extraction solution. Then we're going to move over to these setups, which have a filter, and then that is in a built-in funnel. I don't know if you can see that. And then so the filter's in the built-in funnel, and then if we lift one of those up, you can see that back there, or lift this one up. These are going to drip through the built-in funnel, and then underneath we're going to end up with a test tube containing your solution, which represents your soil. So we analyze these 100 at a time, like Michael said, but we have to do about 10 at a time for this extraction process. And then these are grouped by 50 so that we can work through with some high throughput as we're analyzing the samples. All right, so once we get our test tubes, we're going to move on, but we're going to take a pause and talk about the other section of our soil analysis. So part 2 is a pH analysis, and that prep also happens in this room, and Michael's going to tell you a little bit about that. Okay. So we go back over to where we were with our soil samples.
Once again, and as Dr. Alford mentioned, there's 2 different sizes. One is for this mineral analysis and one is for pH. And these are standardized. This is what you'll find in every lab across the country, as she mentioned. So for pH, it's just a slightly smaller, larger amount. Smooth off and into these medicine cups. And so once the soil is in the medicine cup, we have an automatic dispenser that will add 15 mils of water. And after we add the water, it needs to sit for approximately 30 minutes. And then they go on to a robotic platform where we have probes, pH probes. We have our pH standard of 7 and a pH standard of 4, where we calibrate the machine before each and every run. These go in sets of 100, and then I can show you the machine. It's actually running right now. So this is the dual pH analyzer. This is our pH 7, pH 4, and in the back there's a wash container that's just distilled water. And as you can see right now, it moves from sample to sample, and it stirs. It has an automatic stir, and then it waits approximately 10 to 15 seconds or so after the slurry is stirred. and then it'll take a reading. So it's actually taking readings all right now. And then there's a program that actually will kind of take those readings, and it takes like 10 to 15 different readings while it's in there. And then basically it forms kind of an average, if you will. Now it moves from sample to sample. We don't have that much carryover from cup to cup. But if there are pHs that are very high or very low, say if we can set the machine that if we encounter a pH below 4, it'll go to the wash and wash those probes. If it's above 7, it'll go to the wash and wash those off. We don't wash between every one. But this is actually the second part. What I've done is I've taken a water pH first, and you'll hear all about this. This is now actually the buffer pH. So there's 15 mils of water, and after we take the water pH initially, we add 15 more mils of buffer, and that is basically mimicking the addition of fast-acting lime, and it is almost instantaneous. It's a change. You can see the change in pH instantly. And so what we're doing is we have formulas here in the lab that will then tell us automatically how much lime you need to add to a particular soil at a given pH to change its pH. So as you know, we want most stuff grows between 6 and 7 or 6 and 6.5. We encounter a lot of soils here in South Carolina that are 4.5 to 5. So lime is going to be needed. We do encounter some from the lower part of the state, Charleston and other areas where they already come in at 7. So they won't need anything. It's very easy for me to tell throughout the run if I'm watching the numbers, what's managed soil and what's not. So bunches of low numbers, I can tell, oh, no one's doing anything with this. But the farmers, when I encounter a large batch from farmers, you can tell that they're all generally somewhat managed. They're between the 6 and the 7s. And you can always tell when we've even actually encountered samples where someone's like lime right away, and you can actually see particles of lime in their soil. And it's like, oh my gosh, because it's bouncing around, or it's 8 or 9. And it's like, well, that's because there's lime right there dissolving on the spot. So pH is a very interesting area of the lab for sure. And during the pandemic especially, but we still do, we get soil samples from all over the country now. So we are up into the 30s. I think we have soil from at least 30 different states, approaching 40 maybe. And so when I see pHs of 8 and 9, I can go pull the paperwork. I can see this is from Texas, this is from Arizona, this is from Colorado. It's very different soil types. So it's very interesting. Very interesting.
Okay, so that's our pH analysis for soil. And remember, I talked to you about extraction, which is for the other part of our soil test, the nutrient analysis. So Amy, our chemist here, is going to talk to us about what we do there, but we need to walk down to another piece of equipment. This is our ICP, inductively coupled plasma. If you remember, Shannon mentioned that we have these tubes in the funnel. So that's what we end up with. We end up with 100 samples that are in the batch. We have to be really careful, everything stays in the right order. So we started out with that solid sample, and we added that extraction solution. So we end up with a liquid sample that we are going to actually run on the instrument. So we use calibration standards to calibrate our instrument and generate a calibration curve. And we're going to compare these samples to that curve, and we're going to get concentrations for the different elements. But I'll show you a couple of things. You can see the plasma here, very hot, the flame here. So that's our plasma. And we have some optics in here, and we all have, this is our torch, example of a torch. There's a torch in here. This is also a nebulizer. It's an internal inner. Data comes off the instrument. These are the type elements we have: calcium, magnesium, phosphorus, potassium, zinc, manganese, copper, boron, and sodium. And these are actual data numbers for the samples within that 100 set. Each one has a specific number that we talked about earlier. We do have a lot of quality control mentioned the collection first earlier. We have checks that we analyze, and this green check here indicates these samples are within compliance for the checks. And we have those throughout the run. There's another set of green checks. So this is the data that we generate, and it's going to be on a laboratory report with recommendations. So that's a real fast look at the ICP. I think something that's interesting about this that you might not see in another lab even is the plasma torch that Amy mentioned. So I know this is a little nerding out, but it might show up on your video as well. But this is actually generating the ions that are then counted to get these results. So you can see kind of some of the inner workings. Yep. That nebulizer that's over here. So this is really some very advanced technology that allows us to measure all of these elements simultaneously. Something that most labs who do this kind of work are also using, but it really allows for throughput in our analysis, which is important to us and to the farmer, obviously. So Amy mentioned quality control. Michael mentioned quality control. I hope you understand that we do a lot of work in making sure that we're actually getting good results and correct results to our clients. So we want to know that we actually want to feel good about what we're sending out in those reports that Amy mentioned. So the data that's collected from these computers from this instrument is uploaded to our databases, and what Michael collects over on the pH machine is also uploaded to our database, and the combination of those results is what we use to generate our soil reports. Hopefully you've received one in the mail or email. So that's how we combine all of that data and databases, and then look at the algorithms and the recommendations you're going to get for what you actually need to do in the field. So that's a very quick rundown of what we do with your soil samples. But we can.
Oh, that's right.
Thank you everyone for your patience. This is always always the best attempt at getting things to work properly, but here we go. All right, teamwork makes the dream work, right? So I'm going to talk to you just a little bit more detail about what you already heard from my colleagues in the lab and from me as well. So I'm just going to tell you a bit more of an overview about what we do here at the lab and why we do it. And hopefully for those of you who haven't done a soil test before, maybe if you already have, you'll get a little bit of information about how to do that properly for us. All right, So I wanted to kind of back up, since we didn't give you a real good intro during the tour about what the Ag Service Lab does. So we are more than just a soil testing lab, and I'll briefly touch on this just so you're aware of the other services that we provide. So we also analyze plant tissue, feed and forage, animal waste, irrigation water, and compost samples, and actually a lot of research samples as well here at the lab. So like I said, we're not just a soil testing lab, although that's certainly the bulk of the testing that we do here, since we're analyzing 40 to 50,000 annually. But just keep in mind that we do test those other things as well for our agricultural producers. So who do we serve? Well, as Michael mentioned earlier, we get samples straight from clients in the mail or UPS. So we do serve individual clients and homeowners. Also commercial consultants, growers, extension agents, and extension specialists are usually the ones who samples are gonna come via them or via extension offices to us. And then, like I mentioned, researchers as well are sending us samples, mostly from Clemson, but other state and federal agencies as well. So we do serve a large clientele. So one of the things I like to ask and answer is, why do we test soil? And also, I'll just briefly mention water and plant tissue in a little bit more detail. So generally, hopefully you got an idea about why to test soil from the lab tour. We want to determine plant nutrient availability, so meaning nutrients that are available to your plants to take up, and also the pH of the soil, because as you'll hear from both me and Kerrie probably, that pH is really critical to nutrient availability. So generally, we get samples for growers who are interested in lawns and turf. We have a lot of turf managers and golf course managers who are sending us samples, but also for the homeowners who are growing flowers or, you know, some lavender farms now are becoming popular. And so people want to test soil for that. Shrubs and trees, including forestry, so not just trees in your yard, of course, vegetable gardens, and then certainly the agronomic crops, and also for hay. So a lot of different types of plants and a lot of different types of producers are going to be sending us samples. So the results of your soil test are going to be used, as I mentioned in the lab tour, to generate those recommendations that you're going to see on your soil report. And then not only are they going to tell you what you might need to add, but we also want to prevent imbalances of your nutrients. So we want to prevent you from over fertilizing, so applying too much. So we want to prevent waste and nutrient imbalances that could be occurring with over fertilization. So why would you want to do a water test? I said I'd just touch on this briefly. Well, if you think that there's high salt content in your irrigation water source, whether that's a well or a pond, sometimes there's been a salt incursion. If there's been a hurricane, unfortunately, near the coast, we get samples like that quite often after hurricanes. Or if there's just been some kind of leak that's happened, you might want to test your irrigation water for that. But most commonly, you're just going to be looking at the plant nutrient content in the water sample. Another possibility is if there's been some toxicity, some evidence in your plants, and you want to see if there's something in the water that's causing that. So sample types, like I mentioned, wells or ponds, of course, municipal sources. We have a lot of hydroponic growers who send us samples. Tobacco float beds, samples come in when it's time to start seeding tobacco plants, and so we'll get those as well at a certain time of the year. And then alongside soil testing, a lot of people will recommend you get a plant tissue test. Now we do analyze fewer plant tissue samples than soil samples, but if you really want to get a good idea of what your plant has available to them in the soil and then what they're actually taking up, you're going to do a tissue test as well. So that could be just as simple as looking at nutrient content, but it could also be looking again at something that's causing some toxicity to your plant, identifying a deficiency that could be there, or also you might have some fertilizer that you've tried and you want to just see how it's working, that sort of thing. So again, similar kind of plants that you're going to do a soil test for, you might send us a plant tissue sample. I will just mention really quickly, if there's a disease or a pathogen concern, that actually goes to another lab, a neighbor lab called the Plant and Pest Diagnostic Clinic. So we don't do the pathogen, disease, bacteria, fungus. We don't do any of that diagnostic work. We just do the chemical analysis here at the lab. Okay, so I'm going to, you're welcome to ask more questions about water and plant tissue testing, but I'll move away from those topics. So just wanted to let you get kind of a full idea of what we do here at the Ag Service Lab. So you heard us talk in the lab tour about the two-part standard test we do for soil samples. So I'm just going to go through that with a little bit more detail. You got the really quick version. In fact, we probably could have talked for 2 hours about what we do in the lab because we enjoy what we do back there. But just a little bit more detail. So the two parts to remember are the soil nutrient analysis and the soil pH analysis. And this picture is just a whole set. You heard us talk about a set of soil, so 100 samples that have been scooped. Something that we like to look at is all the different colors of the samples that come through. So South Carolina has 5 big regions for soil type, but you can see certainly more than 5 colors. Of course, color is not always soil type, but a lot of variety of our soil here just in our small state of South Carolina. So for the first part of the test, the mineral analysis, we're looking at the macro and micronutrients. And you've probably heard this if you've taken any kind of plant physiology or soil classes before, or if you've heard something similar in a webinar. So macronutrients are those elements or those nutrients that plants require in large quantities, hence the term macro. So those are listed in green there. And then the micronutrients are the ones that are needed in small quantities. So they're not any less important than the macronutrients, we just don't need as much of them to grow plants. So those are listed there in blue. On the picture on the left there, it's showing you kind of like a food pyramid that we might think about, but what's needed for plants to grow. So nitrogen's at the top of that list, which I'll briefly mention as well. But then these other elements, are needed, you know, in differing amounts. And so we're going to be measuring almost all of those elements in the test that we showed you in the lab. All right. And so like we showed you, you know, quickly what we do in the lab with your samples, but it's really kind of a two-step thing. The soil extraction that I demonstrated for you in the lab is going to be removing those ions that are in the soil, bringing them into solution so we can actually measure them. And then using that instrument that Amy described to you, the ICP. And I saw there was a question on the chat about it's a plasma torch, and I could always talk more about that, but the plasma is just the means for us getting the sample ready so that we can actually count those ions. So we're actually looking at numbers of each element, and that's what the instrument is collecting in terms of the data. So we collect that number in parts per million. And you might have heard that if you've looked at like a soil report, or if you looked like at pool water or water testing, things are reported in parts per million, but we do a conversion to pounds per acre so that when you get your soil report, it makes sense in terms of looking at a whole acre, or obviously more acres for a large farm. So that's why we do that conversion from the number that we collect so that you can make use of that information. So the soil report includes the following elements that Amy listed out for you. So those are the ones that I mentioned we're measuring simultaneously on that instrument, so that then you can see exactly what's in your soil so that you know where to go from there. All right, so the other part of the test, so remember two parts, soil nutrient and soil pH. Soil pH is so important. We talk in the lab, we kind of joke about team pH versus team nutrients, you know, because we try to keep the parts, all the analysis going alongside each other so customers get their results together, of course. But we have a little internal competition about what's more important, but really it interplays with each other, as you'll hear from me and Kerrie. So soil pH determines nutrient availability, right? So we can measure the nutrients that are in your soil, but the pH is actually going to allow, the soil pH is going to allow for that nutrient to either be taken up or not by your plants. So the graphs on the left of this slide just are kind of generic graphs, but they show you just a good idea of what's going on. So remember that, so think back to chemistry class, pH is on a scale of 1 to 14, and the lower the value, the more acidic. So in South Carolina, we have very acidic soils. We tend to, unless, like Michael mentioned, they're kind of from the coast. And then the higher the pH value, the closer to 14, the more alkaline or basic the soil is. So we don't tend to see very alkaline soil here in South Carolina. But if we do come across a sample like that, we definitely do a recheck just to be sure, you know, we've gotten the right result. We even flag those kind of samples. So the second graph is showing you that overall nutrient availability is highest closer to neutral, so closer to the middle of that, the pH scale. And then the bottom graph is just showing you the best plant growth or optimal plant growth is going to happen close to neutral. So really a little bit on the acidic side of neutral is where we're going to see the best plant growth overall. So that's why I said, you know, nutrient availability and pH kind of go hand in hand. To illustrate that just a little bit more, I'm going to show you, this is kind of a heat map illustrating that nutrient availability. So we've got nutrients listed out. So you can just look at each one, nitrogen, phosphorus, potassium down and on down. On the, I don't know if you guys can see my mouse. I'm moving it around and I realize you probably can't see it. But anyway, on the left of the graph is the more acidic side. And you'll see there really aren't a lot of nutrients available except for iron. So green means it's more available in this heat map. And then if you move over to the right of the graph, you're getting more basic or more alkaline. And there are some things that have increased availability there. But we're kind of looking for the area where there's the most green, so where the nutrient is most available at that pH. And that tends to be, like I said, just a little bit on the acidic side of neutral. So that's really where our recommendations are going to tell you how much lime to add. Is the target is generally between 6 and 6.5 for getting your soil pH to that level. And usually we're talking about adding lime. We very rarely are needing to recommend that someone needs to lower their pH just because of where we are with our South Carolina soils. All right, so as you already saw in the lab tour, to do the actual soil pH test, Michael kind of briefly mentioned what we do, but I'm going to talk a little bit more about this so you kind of get an idea of why you see 2 pH values on your soil report. So the soil pH test is itself 2 parts. The first part is we just call the water pH. So that's a measure of the active acidity in the soil. And what we do, what Michael described, he adds 15 mils of water to the dry soil sample and we measure the pH of that slurry. So that's kind of like adding rainwater, you know, to your soil, and then we're just going to see what's the actual pH there. But then the second part of the pH test is when we add buffer, and that's what Michael was showing you in the lab. So the buffer that we add is actually a basic pH, and it's essentially supposed to be representing a fast-acting lime. So what we want to do is we want to take your soil, we're going to add something that's like lime to it, and we're going to see how your specific soil responds to that. So that's going to give us an idea of the potential acidity in the soil, meaning here's your water pH, here's your soil, here's how it acts with just water. But if we add lime to it, are we going to be able to bring that pH up? Is it going to resist change to pH because that's going to tell us something about your soil characteristics, or is it going to be easy to adjust? And based on the water pH value and the buffer pH value, we're going to be able to make a lime recommendation for you that's really specific to your soil and how it responds to lime treatment. So those 2 values go into that calculation for lime that you'll see on your soil report. Or you might have a good pH that's right in the growth zone for plants, and so you're going to see that you have no recommendation for adding lime. Okay, so I'm going to transition to a little bit. I mentioned I was going to talk about how to collect a soil sample. So since about half of you have not done a soil test yet, hopefully you will after this webinar, but just some quick tips on how to collect a soil sample. And we do have some links on our website as well. But there are just some guidelines to follow. So if you have areas that are cropped or fertilized differently that you plan to treat differently, then you should do separate samples for those, because you're gonna need to know, well, how do I treat these separately? If you have different soil types or textures, you probably want to do some different samples, some separate samples for those. And for large areas, we say that 1 soil sample can represent up to 10 acres. That seems like a lot, but you're also going to want to do some subsampling, which I'll talk about in a second. For home gardens, lawns, ornamental beds, 1 sample is usually enough for a uniform area. Now, we do have some people who have, smaller plots that they're working with, but they want to give us some separate samples because maybe the one's in the shade, one's in the sun, one gets a lot of runoff from something, one doesn't. So if you do have some, different managed areas, even in a smaller area, that's fine to send multiple samples. So for those large areas, though, that I mentioned, and the small ones, honestly, you're going to need to take subsamples. So why do we recommend that? Well, if you were to stick your soil probe or your trowel just in one spot, it could have been a spot that you've got a lot of lime in, or a lot of fertilizer hit that spot, or who knows what. So we want your sample to be as representative of the entire area that you're growing in as possible, because we can only give you results based on the sample you give us. So if your sample is not representative of the whole growing area, then the results might not really apply to the whole growing area. So you're going to need to take subsamples, mix them together. So essentially we're kind of averaging the area, because you're going to probably treat the whole area with the same amount. Maybe you've got some specialty spreaders where you can adjust that a little bit based on the area. But if you've got an area you're going to treat the same, meaning manage the same, then you're going to want to do subsamples and mix those all together. So how deep should you sample for soil? So 6 to 8 inches for most crops. So really you're thinking in terms of, I want to know what the plant roots have access to. And so that's where I'm going to sample to. So if it's just pasture or turf, then only 2 to 4 inches is usually fine, wherever those plant roots are going to be. All right, and the thing about if you do have a soil core, which I don't have one. Normally I show one if you're here. Maybe Kerrie has one. Those need to be about the same size throughout the depth. So just imagine if you're digging a hole, so I'm going to do my little visual aid here. If you're digging a hole and you take a V shape out, then whatever was at the top here is going to be over exaggerated in your sample versus what was down at the bottom. So you need to have something that's going to be the same throughout so that we get a good representation of the whole depth rather than an exaggerated, at the top or under at the bottom. So just be sure if you do a V-shaped, with a shovel, just cut a slice out of it and send that to us from multiple places. Okay, so just a little bit of practical things about what to do with the sample. Put the samples together, the subsamples together, mix them up. Don't heat them or put them in an oven. We will do that here. Every sample that comes through, we do that with at a very controlled temperature and humidity. So you can just spread it out, let them air dry a little bit. It'll cost less to ship them to us for whoever's shipping it, whether you take it to an extension office or send it directly, just air dry. And then on your soil bags, we showed you some of those in the lab. If you have soil bags, please do, complete the information on those. If you don't have soil bags, that's okay. We can deal with some other containers, but soil bags are preferable. And you can pick those up from any of the extension offices in every county in the state or here at the lab. Okay, a little bit more. So Michael showed you really briefly about our sample forms. So we do need some information from you. We need to know what you're growing. We need to know your soil type, and then just obviously some customer information. So we have links on our website to help you know what the crop code and the soil code needs to be. You need to label your sample just so we can keep track of it that way. And then there's also links to the soil form. But we occasionally get soil samples with no form at all. And so you're really not going to get a good report because it's not going to have specific recommendations. So if you tell us exactly what you're growing, and we have, I think, over 100 different crop codes for you to pick from what crop you're growing so that the report is really, customized to what you're growing. So please do fill that out as completely as possible. If you need help, you're welcome to call the lab. We can help you. Extension agents can help you. So there's plenty of people that you can reach out to help you fill these out. I will just briefly mention that we do some other tests as well here at the lab that we did not discuss because we were trying to kind of move through quickly. We also will test for organic matter, and Kerrie mentioned that someone had asked about the Haney test. So we do some things that in the lab, including organic matter, that are also done by some of the soil health testing labs. We don't have a soil health test suite here yet. That is something that I have been considering offering for a little while now, but we don't have that in place yet. So ask me again in another year maybe. But we can test for organic matter, which is really important in your soil health. And we do that routinely. Nitrate nitrogen is something else. I told you I was going to talk about nitrogen a little bit. So nitrogen is not an element that we test in our normal nutrient analysis. So nitrogen moves through the soil so quickly and is used up that, in fact, most of our report recommendations just recommend applying nitrogen. However, we can get a snapshot of nitrogen in the soil. So if you've studied some nitrogen chemistry at all, you would know that nitrogen needs to be converted from elemental to a different form for it to be plant available, and nitrate is one of those forms. And so we can measure nitrate. Like I said, it would give you a snapshot of what's in your soil. We can also measure nitrate in plant tissue. So that might, our strawberry growers are usually asking us when strawberries are really starting to grow and develop. We measure nitrogen in strawberry petioles weekly for some of our growers. So there are some situations where you might want to measure nitrogen, and we can do that in soil. We also do a soluble salts test, which is really kind of soil salinity is what you can think of it as. It's measured as a conductivity test. Again, that's usually if you think that there's been salt incursion, some kind of situation where you've got high salt in your soil and you want to know what's going on there. We can measure sulfur in your soil. It's a separate test, or we can just do a pH test as well. So some people just want to know, about a lime requirement, and we can do that. And those options are also on the soil form. Okay, just a little bit more. Some of our clients have accounts with us, and so that's what that account code is for. You don't have to fill that out. And if you go to an extension office, they'll certainly help you fill out the form, like I said. And then we've got some sections that are just for us to use here at the lab, kind of like if you were filling out something for, blood work or something. There's stuff that only the lab needs to use, so just don't fill out those sections. But like I said, anyone who works with extension or here at the lab can certainly get you the help you might need to fill out these forms. And of course, they're available online as well. And there's some instructions about how to do it online. All right, so once you've got your sample, you filled out your form or someone's helped you fill out the form, how to submit a sample. So the picture on the right is actually our loading dock that I think Michael mentioned in the lab tour. So with COVID, we had to really adjust how we did things here at the lab, and we were open the entire time. So we were staffed, open all the normal hours during the entire COVID, and possibly things that might happen in the future as well. We'll still be open. But we have a loading dock where you could come and drop off your samples, pay for your sample with a QR code, ring the bell and let us know samples were there. And so we worked out ways to receive samples, and then the extension offices did as well. So of course you can mail a sample directly to us. You can contact your extension office and see, how they're receiving samples, or bring samples to the lab, and we will handle things. Right now, we're still open to customers coming in the building. I don't know how that's going to change. So just get in touch with us or your local extension office as we see things changing with COVID, unfortunately. But there are many ways to get your sample to us, and we will be open. All right, and one last thing I wanted to cover before I hand things over to Kerrie is how to get your results, because this is something some of our customers are unaware of. So you're most likely going to ask for a report to be emailed to you. If not, if you want a mailed report, it's a $1 charge to cover all the postage and everything. But if you get an emailed link and you click on that, it's going to take you to our results webpage. Now, if you haven't gotten an emailed link, or you lose the email, or if it goes to spam or something, of course, give us a call and see where your result is. But if you want to log into that website yourself, you're welcome to. So you can use the email address you gave us, set up a password, so essentially have an account on that webpage, and you can check your results anytime. You can look back at all your historical results, pull all of that up, and you can access anything that's any result that's tied to your email address, you will have access to. So that's a helpful thing to be able to go in. You just click soil reports. If you had sent us water or plant tissue or something else, you can also see those results here on this website. And there's just some different search features. We're trying to update that actually, so you have even more search options, but hopefully you would be able to go in and find your results under your name pretty easily using the current search features that we have on our website. And that's just for looking at your results, whether soil or anything else. If you find that you need help interpreting your results, I'll mention this, you're probably gonna hear it from Kerrie as well. Go ahead and contact your extension agent, get to know them. They are there to help you, just like we are here to help you as well. But they certainly can help you interpret your soil test and other sample reports from the lab. There's also a Home and Garden Information Center. So this is for homeowners, South Carolina residents only. And they have a call center that they can answer your questions, or you can send an email as well. They get a lot of calls every day, so they are there to answer your questions. That's what they're there to do. And then we have a website as well, the Ag Service Lab does, with a lot of information about soil testing and results. And of course, you can always give us a call as well if you have questions, or email. Okay, I am finished talking about all the things that I wanted to cover. Of course, I can answer questions, but I'll go ahead and stop and let Kelly tell us what we're doing next.
Okay, thank you, Shannon. That was excellent. I'm just going to turn it right over to you, Kerrie, and Kerrie's going to talk to us about actually interpreting some of the results from our soil tests and, you know, what that actually means.
All right, bear with me for just a second while I try to share the correct screen. I have a bunch open. So let's see if we can do the right one.
While you're pulling up your presentation, Kerrie, Lynn made a comment that also the Clemson Extension Helpline is available to, if they can also pull up your soil test results and help you look through them, interpret them. So you probably talk about that a little bit in your presentation, but thanks, Lynn, for that comment.
Awesome. All right, can you tell me, are you seeing the presentation or the presenter view?
Presenter view.
Is that better?
Yep, you got it.
Perfect. All right, we'll see how far I can make it. All right, so hi, I'm Kerrie Roach. I am the horticulture agent that covers Oconee, Pickens, and Anderson counties in the upstate of South Carolina. I'm a commercial fruit and vegetable agent, but I also do a lot of homeowner work, and I've been an extension agent since 2009. I started with NC State and have been with Clemson for the last 5 years. So probably one of the most frequently asked questions that I get is, how do I interpret a soil sample report? You know, people get their soil sample report back and they see this or this, and they get a little bit overwhelmed. And so, you know, one of the first things that I talk with people about is kind of taking out a lot of the fluff. And Shannon probably will hate me for this, but when it comes to the actual application of the soil sample report, for most people, there's a few key things that we want to look at. And so we'll go back to the actual report, but probably the most important things that that I'm looking at when I read a report with someone, number one is that soil pH, and Shannon talked about that as well. Part of that is the buffer pH, and we'll talk a little bit about that. Those nutrient bar graphs are really important. They've changed that. I guess it's been a while now, but previously when I first started in extension at NC State and previously at Clemson, these soil sample reports were much harder to read. They were not in that bar graph form, and it was just confusing. So I'm really excited that that was a change that was made. Those calculations for the CEC, or the cation exchange capacity, the acidity, and that base saturation, and then going down to the recommendations and the comments that are there. Those are all the really important parts that I feel like we can pull out little bits and pieces of when it comes to actually applying that soil sample report back to your farm or your landscape or whatever you're doing. So the first thing, and this is going to be a little bit of overlap with what Shannon talked about, but the first thing is looking at that soil pH. That pH is a measure of how acidic or alkaline it is. And you can see that little graphic just talks about kind of comparing different things, just to give you an idea of acidity of different things on the scale. So Shannon said, you know, it goes from 1 to 14, with 7 being neutral. Here in the upstate, most of our pH of soil falls somewhere in that 5 to 5.5 range. So that's pretty common for me to encounter a grower or a homeowner that has anywhere from a 5 to a 5.5. I've seen as low as a 4, or I've seen as high, this was a first, I saw a 7.9 a couple weeks ago. And so, you know, but what do we do with that? Why is that pH so important? Shannon showed you another graph just like this. This nutrient availability chart is so important to everything we do. I have used this chart in the last 2 weeks, probably 10 or 12 times, just to illustrate to people the change that happens. You know, we talk constantly with Extension about how important it is starting at the base, starting with your soil, and getting that good base groundwork done before you start to plant. And this is really why, because I went out to a land visit today, and they had blueberries. Really nice, great looking plants for the most part. But when you got closer, there were some issues happening. And we'll look a little more at that, but you can tell so much from the leaf, and so much of it is nutrient related a lot of times. And it's because that pH binds those nutrients and makes them unavailable to the plant. So you'll see on this chart kind of those little orange bars, and in between that is usually where we want to fall for most plant material. Now you might say, Kerrie, but you know, I have blueberries, or I have azaleas and rhododendrons. You know, yes, those plants like a little bit more acidic of a soil. If you have a centipede lawn, that's another one that likes a more acidic soil. But for the most part, we're going to look for anywhere between a 6 to a 6.5 in production agriculture. I'm not watching the chat box. So if there is, let's see.
I think you're good right now.
Okay. All right. Oops. So looking at this soil report, this is a typical report that would come back from the upstate. Let me get this off here. This is pretty typical for us. The pH is 5.4. The buffer pH is 7.7. You see phosphorus is high. Potassium is low. Calcium is somewhere in the middle, as well as magnesium, zinc, manganese, and boron is very low. So just locating all those things on the soil sample report is the first part, and figuring out, okay, here are all the things that are important. What do I do with them? We were talking about that soil pH. And so that soil pH is right here, that 5.4. Like I said, that's very normal for us here in the upstate. And so looking back at the nutrient availability chart, that 5.4 is going to fall right here. So notice how these nutrients become much less available. Those bars are very thin. And so that creates a problem for us in the production farming. All right. So pH is really important, but tagged on to that is the buffer pH. And so that buffer pH is the ability of the pH to resist change. So that's how Shannon and everybody else at the lab creates that recommendation. So having that buffer pH, that way they know how much lime to use or to recommend to raise your pH to the proper level. So the lower the buffer pH, so below 8 and lower, the more lime it's going to take to change the pH. Typically, a higher CEC and a higher clay content means it has a higher buffering capacity, like it resists that change more, meaning that that buffer pH is going to be lower. So if you look on this little soil test report down here, there's a soil A and a soil B. And both of these soils have the same pH, but they have a different buffer pH, right? So soil A has a 6.3 buffer pH, whereas soil B has a 6.5. So if we look back at this regular soil pH, we think, oh, okay, you know, they're the same. But no, if I'm going to look at this and think about how much lime I might need to change that pH, this soil A is actually going to take more lime to change the pH than soil B, because this buffer pH is a lower number, which means it has a higher buffering capacity. So that can be really confusing, but the lower away from 8 it is, the harder it is to change the pH. So the more lime that's going to be recommended to raise that pH up. So why is that so important, right? Looking at this, like I said, I went out today, I was looking at some blueberry plants, and there was some really distinct nutrient deficiency symptoms showing up. I've been out to a couple of home gardens and a community garden in the last couple of weeks, and there has been a lot of nutrient deficiencies, and all of it has related back to the pH. And I actually sent in some samples, and I think I've got it on here in a minute. But so these nutrients right here in the circle, this is kind of the basic graph to help us remember. When we look at leaves as extension agents or as growers, you know, you can tell so much from them. And anything that's on the young leaf tissue, so any kind of yellowing or darkening of the leaf or the leaf veins that is on the young leaf tissue, so the very tips of the plant, is typically going to be manganese, molybdenum, calcium, boron, iron, zinc, nickel, sulfur, or copper, right? Those are all going to be on the tips, versus these that show up on the older leaf tissue first is going to be nitrogen, phosphorus, potassium, and magnesium. And so here in this picture, I know it's not the greatest. There's not a really great one picture to show all of them. But it kind of gives you an idea of, you know, we see spotting, we see general yellowing, we see what we call interveinal chlorosis. Zinc is one that shows up really, really bright. Manganese tends to have that kind of dark coloring. Phosphorus will be a dark, sometimes a purple color to it. So this is super important to us to know what's in the soil, and when we see these symptoms on the leaves, to be able to then figure out what's going on. So Shannon talked before about all the things that they test for, but there's really one big one that they don't. And she made a point to tell you that they don't test for nitrogen. Like she said, it is so quick and mobile in the soil that by the time they test, the levels will probably be different. And so when you select your crop code, it's super important to make sure that you're picking the right one. You know, there's so many out there. We have a short list in our extension office that we use most of the time, but sometimes I'll catch myself going, you know, I think there's a better crop code. And they're all listed on the website. So that's a great place to go look, because, you know, the establishment of a crop can have different recommendations versus maintenance of a crop. And so it's really important that you are selecting that right crop code. But here is a picture of a leaf, a soybean leaf, that actually shows manganese deficiency. And so you can see that interveinal chlorosis with the dark leaf veins, and there's quite a few different nutrients that show up this way. So it's really important for us to do that soil test. And they can also do leaf tissue samples for, like she was talking about strawberries. That's a super important one. But let's keep going. So knowing those nutrient levels in the soil, so you've figured out your pH, you've figured out why the buffer pH is important. And then we move down to those nutrient levels and knowing, you know, where are they at? So this is pretty common in a lawn situation, having a high phosphorus over the years of fertilizing and that, you know, sticking around. We see this a lot, but giving ideas of those ranges that are good or low, medium, sufficient, high, and excessive really gives us a good visual to help figure out where we need to be going with our next application. The cation exchange capacity is that holding capacity for the soil cations. And typically we're going to see a high clay content equals a higher CEC. And so it's just really important to know these types of pieces of information so that we can get a good handle on your soil as a whole. And I'll keep going because I know Shannon talked about a lot of these. But the last thing that is always put on your soil sample report is those recommendations at the end. And a lot of people skip over this or don't even realize that they're there. And these little comments that you see here, see comments 1, 105, 514, 517, super important. And actually we can go back because this one has the comments written right on there. And so it's really important to go ahead and read those. You know, 118 says 2 cups or 1 pint of fertilizer is equal to approximately 1 pound. 3/4 pint limestone weighs approximately 1 pound. This is good information that you don't have to dig up. They have it right here for you. So make sure that you're reading those comments that are at the bottom of your soil sample. They're going to help you kind of demystify that information. So you've got all of these pieces of the soil sample report, but the question is, what do I do with it? So the first one we talked about was your pH, right? So typically in the state of South Carolina, you're going to have to raise your pH. Like I said, most pHs are going to be low. You want them somewhere from 6 to 6.5 for most crop production. That's going to involve liming, whether it's pelletized dolomitic lime or fast-acting limestone. So a lot of times as extension agents, we really recommend that you do fall soil sampling so that you can get your test results back and go ahead and put out lime so that it's activated in the soil and can then be ready for planting in early spring. One of the things that you can run into as far as liming is that using a fast-acting limestone can be a little bit more expensive, and it can also leach through the soil or move through the soil too quickly, and you're not going to get the change that you are wanting. So for an example, if your soil report recommends that you spread 50 pounds per 1,000 square feet on your vegetable garden, that is 50 by 50, okay? How many bags of lime do you need? Okay, so let's kind of break this down. We're bringing this to the store. We've got to figure out, first of all, how many square feet is our garden, right? So 50 by 50, right? We're looking at 2,500 square feet, right? So I see the chat box. I can't see it. Where'd it go? Yep. So 2,500 square feet. And so we are going to need 50 pounds per 1,000, right? So we have how many thousands, right? 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,0 Oh, I see, 125 pounds. So, all right. So how many bags of lime do we need? Anybody want to guess how many pounds are in a typical bag of lime? Good try. So they like to make it confusing for us, right? So most bags of lime actually come in a 40-pound bag, which 50 would be easy, right? But no. I think you can get 50 every once in a while, but most of the time it comes in a 40-pound bag. So 125 pounds means we would need 4 bags at 40 pounds per bag. So, you know, it's always difficult. But this really is an easy soil calculation for when we're dealing with soil reports. So this is one of the easy ones. But so just trying to figure out, you know, knowing how many square feet. I went to the garden supply store yesterday and I was looking at putting out some grub control. I have a huge problem with grubs in my lawn. I've tried a lot of other things and I've got to do something about it. And so I was trying to calculate how many square feet I have in the lawn. And if you haven't memorized it yet, memorize how many square feet are in an acre. Because I can't tell you how many times I look it up. If you're not sure, it's 43,560. But I always check to make sure. So that's really important. It's also important when you code your crop. Make sure that you code it correctly, because there's a lot of times where somebody's growing a home vegetable garden and they choose tomatoes or, you know, a commercial crop code where that's going to come back in tons per acre. And I know we can go back to the Soil Lab and have it recoded, which is awesome. Because I've had to do quite a few where you break it down from tons per acre to, you know, somebody's 150 square foot garden. So this is the easy side of it, figuring out that lime, how much you need to get it to the right pH, right? So next thing is looking at fertility. So here's a fertility recommendation. Oh, here's a fertility recommendation. So it says that we need 100 pounds of P2O5 and 60 pounds of K2O. So when we go to the garden supply store, how do we know what to get? How do we know what to get? Or if we are getting, you know, if we're using compost or manure, if we're using bone meal or blood meal, how do we know what we have? Well, first we're going to look at that guaranteed analysis. So if you're using synthetic fertilizer or organic fertilizers and they're commercially sold, they have to have a guaranteed analysis on the label. And that label is going to show you those 3 numbers, right? So N, P, and K. So on this bag, the numbers are 18, 24, and 12. And so that's the guaranteed analysis of this fertilizer. That's what is in the bag. And so this number tells us it is a percentage of what's in the bag. So for this little clip art, we have 18% nitrogen, 24% P2O5, and 12% K2O or potash. So if this is a 50-pound bag, I really only have 9 pounds of nitrogen, 12 pounds of P2O5, and 6 pounds of potash, right? So remember, this is a percentage of what's actually in the bag. So if I have a 50-pound bag of 0, 10, 6, can anybody write in the chat box how many pounds of phosphate or P2O5 are in that bag? How many pounds of phosphate are in the bag? That's right. That's right. 5 pounds. Thanks, Lynn. So yeah, so there's 5 pounds of phosphorus or phosphate and 3 pounds of potash. So there's a lot of inert. Kerrigan asked what makes up the rest of the bag. So there's a lot of inert ingredients or carriers to be able to bind with that and make it more soluble, or how it is spread. So sometimes it might make it easier to spread. Sometimes it might make it water soluble. It just depends on it. But you can look at that guaranteed analysis on the bag and it will tell you exactly what is in there. All right. So, sorry, I have 2 screens. All right. So one of the tools that I want to show you is that, you know, we can't always know for sure how what we have or what we're trying to do. And there's so many fertilizers out there for us to choose from. So this is a really great tool, and I'm actually going to, well, I'm going to show you in a minute. This is actually a fertilizer calculator that's going to help you figure out fertilizers. We're going to come back to it because I want to go through and show you these other things, and then we'll go and see a bunch of different websites at once. All right, so another one that I want to show you is the Southeast Vegetable Crop Handbook. This is 2020. There's a 2021 version. I'm going to give you all these links in a PDF when we finish. But the Vegetable Crop Handbook is all of the commercial vegetable agents across the state have boxes of these. They are amazing resources. They're about 3/4 of an inch thick. It goes through every vegetable crop in the state that we grow, gives planting dates, recommendations, pH for each crop, nutrient recommendations, all the things, whether you're doing it conventionally, organically, sustainably, somewhere in between. There is information for anybody out there. So if you have not gotten a copy of one of these handbooks, I highly advise you to get up with your commercial fruit and vegetable agent that's in your area and get a hold of one of these. It is available online, and I will show you that here in just a minute as well. So in the handbook, there are general recommendations. So if you haven't done your soil sample or you want to compare it to commercial recommendations, there are some general fertilizer recommendations for vegetable crops, each of them, in the Vegetable Crop Handbook. And so you can see them here. They're pretty small, but starting at the top, you'll have asparagus with a desirable pH of 6.5 to 7. That's a little bit higher than a lot of our other crops. Nitrogen, pounds per acre, it's recommending 100 pounds per acre. 250. So here, if your soil phosphorus level is low, medium, high, or very high, it actually changes those out to give you correct recommendations. Again, this is without a soil test report. So this is a really good thing that can go hand in hand with your soil test report, because I highly recommend you get your soil testing done and then use it as a tool with this if you're doing vegetable crop production. Some of the nutrient values for manure applications and crop residues. So this is a really good kind of cheat sheet that's a part of that Vegetable Crop Handbook to give you a base idea, a generic idea of if you are using things like poultry manure, or alfalfa sod, or hairy vetch, or crimson clover sod, things that you might be using as a cover crop or a manure application to provide nutrients to your final crop. And so this is just a kind of a general rule or a general nutrient value. They could be a little bit different or very different from this. So it's important that you get yours tested if you don't know, what you're dealing with. So let's look real quick at some organic fertilizer sources. There's actually some really good sources listed on this site, and I'll give that to you as well. We're going to look at cover crops and how much they can supply as far as nitrogen. So if you are doing cover cropping in production, your nitrogen divided by 2 is a rough estimate of the amount of nitrogen that's available for the subsequent cash crop. And we're going to look at an actual calculator for that. If you are looking for sources, again, sources of nutrients, sorry, had a brain fart. Sources of nutrients, some great sources of nitrogen. These are the ones that are referenced in the link that was previous. The first one is obviously doing cover cropping, and some of those are listed in these, but blood meal or bone, crab waste, feather meal, fish meal, hair, shrimp waste if you're on the coast. Those are some great things that you can use. Phosphorus is bone meal, hair, mushroom compost, shrimp waste, and potassium, crab waste, kaolinite clay, kelp, wood ashes. So these are some really good lists. If I'll share that link previous, and you'll be able to go through and get the whole big printout of it. There are some general analyses again, to give you an idea of what those might provide back to your growing system, to your soil. But it's really important that you are, you make sure you know where you're getting your crop from, and it can be tested so that you can get that. So let me show you. All right, I'm going to start sharing my desktop. We're just going to do this. All right, so can you see my actual desktop? Right now you see this important information and links.
Nope.
Nope, we're just looking at you, Kerrie.
Oh, wait, I didn't hit the share button. There we go. Now you got it?
Yep.
Okay. Kind of have to hit the share button. So like I said, I was creating important information and links for you to have, but we'll slide that over here. And so one of the first things that I'm going to show you is finding your extension agent. So here in the upstate, these are the three.
Kerrie, could you
yeah.
maximize those pages while you're looking at them?
Yes.
Great, thank you.
Oh, shoot. All right. So here in the upstate, I cover Oconee, Pickens, and Anderson. If you click on any one of these counties, what you will do is you'll come to the county office page. You can then click over here on staff, and you will see the different agents that work out of that office or that cover that office. So anything from livestock, forestry, agribusiness, we have a health extension agent, water resources, and then you see my name, the area commercial horticulture agent, as well as contact information and email and phone. So you can even click on their name. It'll give you a little bit more information about them. I guess I should add a picture at some point. So this is a really great place to find who your extension agent is. So let's see if you are in Edgefield County and you were a vegetable or fruit producer. The commercial horticulture agent there is Sarah Scott. And so this is her contact information. If you were doing timber production, Stephen Pullman would be who you would contact. And so anybody within these offices can get you to the right person. All right, and so I will share that link with you right here for the county offices. It's just really easy to click and go. And this is another place where we were talking about soil samples. If the office is not accepting soil samples, it should be listed here on their front page. Or if you want to go ahead and call before you go to drop off samples, you can contact them right on their main page. All right. Next up is the Home and Garden Information Center. This is a great place to get all sorts of information. So if I were doing, let's see. Oh. If I'm trying to find, just because it's my favorite, we'll search apples. So we can look here and find information about apple production in South Carolina. Gives, just all that information that you might want. There's lots of fact sheets, lots of information. They have a blog with different posts multiple times a week. So it's a wealth of information. You can type in anything. Something you guys might have noticed is you might see webs in your trees. It's kind of off topic, but again, that's a topic that you might find on the Home and Garden Information Center. All right. So let's go. Next up, if you are a commercial fruit and vegetable agent or commercial fruit and vegetable producer, the South Carolina Grower is a great resource that the commercial fruit and vegetable agents have started. This is actually a blog. So you can see here's today's update from, this has Zach Snipes, Justin Ballou, and I think myself were the three that submitted today. But you can see what's happening. Justin said last week was by far the hottest. It doesn't take long for caterpillars to significantly damage brassica seedlings. We put out pictures. Zach's talking about root knot nematodes. And a lot of times we might give recommendations or how you might mitigate that. We do once a week blogs unless there's something important happening. So for instance, our plant pathologist, Tony Kyneth, put out some information about gummy stem blight. And so that's an important thing. So we made an extra post for it. But again, there's going to be photos, information on how to deal with it. And it's what's going on throughout the whole state. You can search the page by keyword. You can add and follow us so that you get an update when things are happening. The other thing we also have is a podcast. So we put out an update today. Tomorrow, we will actually get online and record a podcast. So you can listen to it while you're in the car and find out what's happening throughout the state. We usually invite a specialist in to talk about a specific timely topic. So it's a really great resource to have. Remember that crop handbook that I talked about and said was a great resource? It's linked here in the crop handbook section. You can see the vegetable growers handbook. There's also the peach and nectarine and plum handbook, as well as the apple handbook. And those are links to the actual free ones online. you'd have to request a hard copy from your local agent. All right. Next up, we talked a little bit about, let me maximize this, predicting nitrogen release from cover crops. So if you are using cover crops in your farm practices, this is really, really important to you, knowing what's actually going back into my soil from the cover crop. Why is it so important to me? If you don't know what you're putting back in, then it's just a guessing game. And so this is the actual PDF that talks about the nitrogen cycle, why we use cover crops, why it's so important. And then we move to the actual cover crop calculator. So if you're not using cover crops, you should be. But here is the calculator that's available from the University of Georgia. And there are instructions with it. You just click right here in this middle section. There's also a place to contact someone if you need help. But if you have a lab number, you can enter it there. That's for Georgia. So if you don't have a lab number, that's okay. But you can actually select here for a crop. What is your target nitrogen fertilizer rate? So if we say 50 pounds per acre, we're just going to pick today. And we don't want to grow Lespedeza. Let's grow something in the fall. All right, we're just going to pick something. Beets. Ha. What is the cover crop? We're just playing. We're going to go back. Oh, I guess we can't.
Kerrie, just a heads up, we have about 13 minutes left till 5 o'clock.
Okay. So anyway, it's a great tool when you're putting in actual crops, trying to pull one and just play around with it. But what's going to happen is it's going to actually give you those results so that you know how much nitrogen is available from that cover crop, which is a really important tool for growers to be able to use. Another tool, the last one, hold on. It's on here, actually. The last one I can show you is that fertilizer calculator. So remember we were doing those fertilizer calculations, and sometimes when you go to the store, the things that you find, or you go to the garden supply store or the feed store, things that you find are not always what's on hand. And so this is a great tool to have because you can put your recommendation from your soil test report here in the box. Let's see, 16. And what it will tell you is that's how many pounds per acre. That was my recommendation. And now it's going to tell me pounds per 1,000 square feet. So remember when I said it was such a pain to have to calculate it out? This actually calculates it for you. So if you happen to put a commercial recommendation, or if you just have a smaller area and you need to go from the pounds per acre down to pounds per 1,000 square feet, this is a great tool. You also can choose from some common NPK formats. So things that we typically find in our lawn and garden store, or if we're looking at farm use, if you're going to the farm supply, these are common fertilizer analysis that you find. And so you can go through and it will help you kind of weed out the parts and pieces that you're looking for. So, yep, I saw in the chat box, somebody was asking about those sites. Yep, all of these links are going to be sent in that PDF. They're all actually listed right here. So I'm already trying to get a step ahead as we have the chat box. So this is a great tool. So it's really just so important that when we get that soil test report, we don't just say, oh, okay, I did my soil test, check. Take that test, get a hold of your agent, take it with you to the feed and seed, use some of these tools, help try to figure out a real application to your actual production, how you can use that soil test. Because sometimes it's a little daunting and it doesn't all come out as, oh, you need to apply 50 pounds of 10-10-10. Wouldn't that be easy? Wouldn't that be easy? Or, you need to apply 85 pounds of poultry litter. Wouldn't that be the easiest thing if it was just that way? So these are some tools that work really well to help kind of mix and bridge the gap between the soil sample report and what you actually need and what you can find in the store or what you're using as fertilizer material. So it's a lot. I'm going to send the links. I'm more than happy to help. If you have questions or problems, just let me know and I will get you in touch with your agent, or I'll help you as much as I can. And I know Kelly and Shannon are all willing to help as well. That's all I got.